Hello, science students. Welcome to today's lesson about air mass interactions. As you might recall, air masses are these large areas of air, and they form and can have different characteristics. The characteristics that they have depend on where they form at. Air masses that form over a continent have different characteristics than air masses that form over the ocean. Here in this diagram, you can see several different types of air masses and where they form, as well as their characteristics. Those ones that form over a continent tend to be very dry. Those that form over an ocean have lots of moisture. Ones that form up very high in the latitudes in the Arctic are very cold. In the polar area is cold or cool. And then ones that form in the tropics are warm. We've got all that information here in a nice little table, but if you understand the naming process of an air mass, you can understand the humidity and temperature that's found there. Continental are dry, maritime are wet or moist, and tropical are warm, polar are cool or cold, and Arctic are very, very cold. They're abbreviated with a lowercase letter for either continental or maritime and a capital letter for where they format in the latitudes. Remember that these air masses form through convection currents and are both created and moved by the jet stream up above them. When the jet stream sits in a location for a long period of time, an air mass strengthens. You get a larger and larger air mass with more and more of the characteristics of that place. When that jet stream moves, it can kind of push those air masses around. For instance, at the beginning of this animation, you can see an air mass that forms over Texas, and over time it gets pushed up into Colorado. Or there's another air mass that's formed up in Canada, and that kind of gets pushed down into New England. Where these air masses interact, they create what's called a front, and that's the location where two different air masses meet. We classify them into either warm fronts or cold fronts. A cold front forms when cold air takes the place of a hot air mass. So the cold moves in and pushes the warm air up and out of the way. This can create lots of towering clouds that develop into things like rain or snow showers, thunderstorms, and have very, very strong winds. These cold fronts move very quickly as that dense air in the cold air mass goes rushing towards the lower pressure, the big empty spaces in the warm air mass. Vice versa, a warm front occurs when warm air moves into an area and tries to push cold air out. Since the warm air is lighter and less dense, it kind of rides up on top of the cold air as it's pushing it from behind. This creates some lower level clouds. Notice they don't quite tower and have that big thunderstorm look. And these warm fronts move much slower because it's much more difficult to push the heavier cold air out of the way, and that warm air tends to slide up it as it's pushing it out. When two fronts kind of travel next to each other but don't really bump into each other, you end up with a stationary front that kind of sits there. And then we can have this weird situation that's called an occluded front, where three air masses interact. You've got cold air that has a warm front coming behind it, and it's trying to push that cold air out of the way. As that warm front is pushing on the cold front, another cold front actually comes in behind the warm front and collides and sandwiches a warm front between two different cold air masses. This pushes that warm air up and can create very, very strong storms. We look at a weather map, we use red symbols for warm, blue symbols for cold, and fronts have either triangle for the cold or a semicircle for the hot that point in the direction that these fronts are moving. For instance, both that warm front and that cold front are both moving up towards the top of your screen. Here on this map, you can see that we have a blue letter H that is represented by high pressure. This is very cold, dense air. The red L is low pressure, very warm, spread out air. And then on the red line, you can see we have a warm front moving kind of down to the southwest towards Los Angeles and Southern California. Next to it, we have an occluded front where a cold front is being pushed by that warm front, and then there is another cold front behind it. We have two cold fronts that also occur. Here's a forecast map from the National Oceanic and Atmospheric Administration, and it shows the type of items to expect. For instance, thunderstorms over the Missouri, Illinois, Iowa area, compared to rain up over the coasts of Northern California, Oregon, and Washington. It's so difficult to predict the weather because there are so many variables that can change. A change in temperature can affect the weather. A change in pressure can affect the weather. A change in the amount of water vapor can affect the weather. If an area reaches a dew point, that can change the amount of water vapor as well as the temperature of that air mass. Same thing can happen as it crosses different geographic features. And all of these factors are changing things that might occur at a very precise location. And all of these factors happen to change very quickly and very frequently. But we're able to get pretty close because we have lots of different locations that have scientific instruments measuring these conditions. We've got thermometers all over the place measuring the temperature of the air. We've got barometers measuring the changes in pressure all the time. We also have hygrometers that measure humidity and the amount of water vapor that's in the air. We have anemometers that measure wind speed and direction. Different weather models use this information to create what we call our weather predictions. There's several different models out there, and a weather forecaster uses multiple models to try to see if several of them tell them the same thing is going to happen, or if they get lots of different outcomes. Some weather models that I enjoy using are the National Oceanic and Atmospheric Administration, NOAA, and they've got great satellite views that are updated in real time, like every 5 to 10 minutes a new data point goes in. And I think they have some of the best long-term forecasts, things to look at 4 or 5 days out. If I'm trying to plan what to do on my weekend, what type of weather to expect, I go look at the NOAA website. My day-to-day, real-time type of stuff, I do like the Weather Underground app. I use it on my phone. I can look at it. It'll tell me the temperature. It has pretty good predictions about when to expect rain and things along those lines. And that's because they gather information from very localized sources. These are like weather monitoring stations that people put up at their house. They can provide that information directly to the app, and it uses that information. And they can find information on places that have 3, 4 different weather stations very near to me in my neighborhood. So I like that one a lot for my what's happening right now. Do I need a coat as I walk out the door right now? All right, thank you for your time, and I hope you have a wonderful day.